This is the tutorial for step 5 of FORCsensei processing, and this is where we're going to define the different models that are going to be considered during the regression process. Now this is where things get a little bit complicated, but we start off just by clicking model options, and you can see we've got a number of tabs in the menu, one called model ensemble, one called downsampling, and one called processing. And these are going to allow us to define the different variFORC models that are going to be compared, how we compare them, and are we going to use parallel processing to do it. So first of all, do we want to work with magnetizations or lower branch subtracted data? Just to go back to our data, these are the magnetizations, these on the right are the lower branch subtracted. So we make a decision as to which of those we're going to use. In this case, I'm going to work with lower branch subtracted, so I just keep that button as it is. Now the smoothing parameters refer to variFORC smoothing parameters, so if you're not familiar with those, I would recommend that you go and you read the variFORC paper. But what we're going to do is compare a number of different variFORC models. So we're not selecting single values for each variFORC parameter, but instead we're giving a range of values that we're going to consider. So for example, in the horizontal smoothing range given by SC, we're going to consider ranges of smoothing factors from 2 all the way through to 10. And if you wanted to adjust this, you can just use each side of the slider. So for example, if we wanted to compare maybe 3 through to 7, we can just pull the slider as appropriate. Of course, we can return it back to our original values. Like I said, that will now compare horizontal smoothing factors between 2 and 10. We can do the same thing for the vertical smoothing factor. Again, it's set at its maximum range, which is going to compare smoothing factors between 2 and 10, but you can use the sliders to change the extent of the parameters that you're going to compare. Now lambda is also a key parameter in variFORC smoothing. That's how the smoothing increases as you move out towards the edges of the fork diagram. Again, we're defining a range of values to be compared between 0 and 0.2, and you can use the slider to change the maximum value to be compared through to the minimum value to be compared. Now, as we change these sliders, what you'll be able to see is it will tell you how many different variFORC models are going to be compared. So at the moment, using these full ranges, we're going to compare 546 different variFORC parameters. So contained within these ranges are 546 different models that will be compared. For example, if I change the number of horizontal models, you can see this comes down to 192. So we'll be comparing less models, but we're also considering a smaller parameter space. So again, I'm going to turn that up. Now, there's an additional option here where we can assume that the minimum smoothing for our variFORC parameters in the horizontal and the vertical is actually the same. This is often a useful assumption to make. It avoids the generation of some artifacts, but it isn't always going to be the case that you want to use that option, in which case you can just uncheck the box. You can see the number of variFORC models we're now going to compare has grown dramatically from 546 to 2,646 because we're no longer assuming this constraint on the parameter space where these two are equal. But it is possible to either use that assumption or not use that assumption, and that will control the number of models that you're comparing. So because I want this to go relatively quickly, because it's just a demonstration, I'm going to limit these a little bit. Maybe I'm just going to do my analysis between 2 and 8 in my smoothing, and I'll maybe reduce my maximum lambda down to, say, 0.21. You can see now I'm going to be comparing 220 different models. Now for downsampling, this is explained in our paper in detail, and I'd suggest you read that for more information. But for the model selection statistic, how many different locations are we going to consider? We'd recommend 2,000. You can actually turn this all the way up to include all the data points in your data file. But if you do that, the calculation is going to take a very long time. So as a compromise, we recommend that you actually use about 2000. Even if you can't hit 2000 with the slider, you can just type in 2000 here and it will use 2000. Now for processing, we use a multi-processing engine called Dask, and you need to define how many Dask workers are going to handle the job of calculating all these different VariFORC models. Now at the moment it's set on 4. This is a value that should work on most laptops and cloud services without challenging your CPU or memory. If you're trying to do this on a high performance computer, you can ramp up the number of Dask workers or multiprocessors. We've set a maximum of 20. For my laptop, I know that I can run with 8 Dask workers without a problem. Now what will happen is actually if you select too many Dask workers, it'll throw an error and you can start again from the beginning. So if you're being conservative, I would suggest using 4. If you've got a slightly more powerful laptop or desktop, you can work with 8, and then you may need to experiment a little bit for your system to see how many workers you can actually use. But the larger the number of workers, the more CPU and the more memory will be dedicated to FORCsensei, and you'll get through that comparison of the different VariFORC models more quickly. So we've set out the number of Dask workers, we've set our downsampling, we're only going to consider 2000 different points for the estimation of our model selection statistic, and we've set our VariFORC parameters. We're working on lower branch subtracted magnetizations. We're going to assume that SC0 equals SU0, and now we're ready to go on our next step where we'll actually start to perform the regression model comparison.